Hey there, welcome back to the channel. My name is Chris, and today on C# and Sensors, we are going to get the state of charge of a battery on your embedded device. We're going to use this, which is a MAX17043 part. Let's take a look at it closer. So this is the MAX17043 breakout board. We've got a JST connector, which is a standard connector for lithium batteries. Got another couple of pins I soldered on so that we can get access to the same pins from here. We'll see why here in a little bit after we run the application. And then on this side, we've got 6 pins. These are things like power and ground, as well as an interrupt for low power condition. And then over on the other side, we have the battery, or not battery, but we have the input voltage to power the chip and ground. So the wiring here might look a little confusing, but it's really not that complex. Let me explain it. We've got these 2 wires here, which are I2C clock and data lines, and those come over. And then over here, we also have power and ground. So it needs to be powered for the chip, but it also has the power and ground for the system, you know, for the voltage bus. And those are separate. So you have to run the power and ground over to power the chip separate from the battery lines. Now the battery I have plugged into this Meadow F7. This has a charging circuit built into it, so it's got this JST connector that goes over to the battery. Now this does not have a way to give you anything other than just the voltage on the battery, so it doesn't give you a good state of charge. So that's why we're adding this in. Now the state of charge, the gas gauge over here, it has to connect into the same system. Couple of options. I could have had like a Y connector, so come out of here into something that goes to both. You can see this one again has that plug on it for a JST. Since I don't have a Y connector like that, and in fact I looked around but I don't have any JST pigtails at all, I just soldered onto the back side of this a couple of wires, and those come over to the plus and minus on this. If I had another JST pigtail, something like this, I could have come off of here and onto this connector as well. So it's not overly complex, it just looks a little bit strange. Basically, this goes in parallel to the battery in whatever your configuration is. And then we've got the communication lines that come back to the Meadow. Let's go create an application for this. I'm changing it up a little bit today. Instead of using the Yoshi Pi, I'm going to use a Meadow F7. The reason for that is this has built-in battery charging already. Now the downside is we don't have a display, so we can get a nice visual of the output, but we can still use the console. So let's create an app using the Meadow F7 Feather as our template. We'll call this our battery monitor. This template creates a very simple application. We're going to remove all of the references to the LED because we don't actually care about the LED for this sample. Next, we'll add a NuGet reference to the MAX17043. This library supports the 17043 and the 17044, so 1 or 2 cell batteries. All right, then we come back here, and as usual, we will define and create an instance of our sensor. The 17043 and 44 takes an I2C bus. There's only one possible bus address for this part, so you don't even have to provide it an address. Now you can pass it in here an interrupt pin and a threshold %, so it will set an interrupt if, say, the battery is below 25%. The percentage you can select anywhere from 1 to 32%. In this case, I'm not going to provide it, we're just going to poll it, but if you wanted to implement this in your solution, an interrupt is probably a cleaner way to do so. Now down here in run, I'm just going to create a loop, and in the loop every 5 seconds, I'm going to report back the voltage and the state of charge of the battery. Actually, we'll just update it every second for this sample. So you can see how easy it is to use this sensor. Half a dozen lines of code to define, create, and read it. If we were doing this interrupt based and wanted to get notified when it changed, it'd go up by maybe another half a dozen lines of code. I'm going to deploy this and we'll see how it runs. I launched the app from Visual Studio, but because the output window has a small font and I don't feel like messing with my install of Visual Studio, I'm just going to listen to it from a console here. So you can see once a second, it is outputting the current voltage and the state of charge. It is at least interesting to note that the voltage here, it says 4.17, and this is a 3.7 volt battery. That is because it is currently plugged into USB, so it is accepting charge from the 5 volt system. If I unplug it, that voltage will go down, but I will also lose my connection that is telling me what the voltage is. And there you go. That's all there is to getting the state of charge and the voltage on the battery for your embedded system. Again, this is on a Meadow F7, but this would work just fine on something like a Raspberry Pi, a Jetson, a BeagleBone, anything that has an I2C device that you want to run on battery power. Thanks for watching.